I think looking at what has been done already, really imaging biomarkers look to be the more consistent, and there's been more thoroughly studied. And when I say that, looking at things such as, caudate or putamen volumen, and the progressive atrophy we see in Huntington's disease even before the clinical symptoms are apparent. I think another exciting and perhaps more recent discovery is looking at wet biomarkers, and in particular a molecule called neurofilament light chain, which is not specific of Huntington's. It's kind of a marker of neuronal death, but it seemed to have interesting results, at least to state. And of course, ultimately, what we would like is a biomarker that links us directly with Huntington and the Huntington pathway. And so really, as of yet, we still don't have a biomarker that allows to do that. And as you can imagine, that can have different applications, from not only, for example, target engagement. We talked about novel disease-modifying therapies targeting the Huntington pathway. So it'll be nice that we have a direct marker that tells that that's happening in the brain, but also as a potential determining what's the effect these therapies will have. And if we are the premise that they can reduce Huntington, then will be very good, even from an earlier stage of development, that we can document that. Ultimately, I think if we think broader and perhaps more into the horizon, into the future, if these modifying therapies, if we find one, we'd like to test them in people that have not developed symptoms. And so having robust, valid biomarkers at that stage will be quite valuable, and I would think fundamental to test these drugs in that stage of Huntington's.